Okay, everybody, thank you for attending today. So my name is Tony Burns. I am responsible for the PELCO business in Ireland. I've been in the security industry approximately the last 20 years, and the last 9 of which have been with PELCO. We're going to touch today on IP CCTV. As you're all aware, the industry, CCTV industry in particular, has gone through dramatic changes over the past 5 years in moving from analog to IP. I just want to touch on some of the considerations with that. PELCO as a manufacturer has been in the IP field for in excess of 10 years now, as many other manufacturers have been. However, it hasn't been widely adopted because of economic circumstances over the past number of years. If you look at the business in Ireland, there's many systems in Ireland which are in excess of 250 to 500 cameras. The largest system we have globally is in excess of 10,000 cameras, so it is very much a proven technology. So briefly, just going to look at comparison of IP and analog, some of the integration considerations, and then the ONVIV standards. ONVIV, as many of you will be aware, is the sort of industry forum now for recognized standards, so things interoperate together. We're just going to touch briefly on those standards. So we take traditionally what we're used to. The analog world, everything was centered around a single point, typically a matrix solution, and off that, maybe multiple keyboards, multiple monitors, and the cameras all connect. So everything cabled back to one central point. Recorders and so on tend to be located with the matrix as well. There's obviously a large amount of copper, a large amount of infrastructure in one central point. As we move to IP, the only central point is the network, and the network can be distributed across a building, a site, or further afield. As you can see on this, all the devices hang off the network switch, so all your cameras, all your decoding for viewing devices, monitors, etc., control devices, and integration, typically to third-party systems, all links around that network infrastructure. In an ideal world, that's where we jump straight to, but people who have made investment over the last maybe 5, 10, maybe even 15 years don't want to throw away the investment they've made with the analog technology. So what we see commonly is a hybrid solution as the first step towards an upgrade of a system. So matrices and control equipment can remain in place, but the recorders tend to change and then have the ability to bring in analog cameras, but also then have the ability to bring in IP cameras. Over time, you can be left with a completely IP solution with all viewing off the IP solution, including remote access from mobile apps or across a site. Encoding is a critical part of that. Encoding is basically a means of bringing an analog signal in and allowing us to bring it onto an IP path. Ultimately, those encoders can be a directly attached device to a particular recorder, or they can sit directly onto a network, and the recorders can sit anywhere on a site or on a global location, as long as there's a reasonable bandwidth path between those points. The camera technology. A camera's a camera, you could argue. Cameras are there to do a particular function, to look at a certain area, to be able to pan, tilt, zoom, whatever the application may be. So the camera technology, in terms of what you look at on the images on the screen, looks largely the same. But there's been a lot of advancements in the technology over the last number of years. One of the key things is obviously the use of megapixel technology, and we'll touch on some of the resolutions and detail within that. One of the big steps has been the use of higher resolution cameras to be able to provide more detail within a scene, and from that to be able to digitally zoom in to parts of the scene. So for example, this is a scene from a panoramic camera. It's got the ability from a 180-degree scene there to be able to zoom in and pull up certain information on sections of it. So potentially you can take your installation from multiple cameras down to potentially a single camera. Each of those areas or cells you see are drawn out can be basically put onto separate monitors, or separate information can be there for live and also for playback. You have the ability with multiple or single imager sensors where you have the ability to generate a 360-degree view. The advantage of this, if you look at the image on your right, the shop scene, that's a single imager covering the entire location, in this case a cafe. From that, you can use the digital zoom capability to zoom in, see the food preparation, to to see transactions across the till, to see customers who are sitting at the rear of the cafe in a seating area. It's a lot of detail from a single camera. Obviously, single camera means we're reducing installation costs. All that's made possible by increases in resolution. So we talk about megapixel technology. What I find when I chat to many people is there's an understanding of what megapixel is, but if you actually ask what is a pixel, very, very few people can answer the question straight. So very, very simply, a pixel is a picture element. It's the smallest dot on a screen you can see. It's made up of a digital red, green, and blue value. So for example, if you look down the right-hand side, red, green, and blue are all set to values of 0, you get black. Red, green, and blue are set to values of 255, you get white. That's a pixel. That's how the images are made up. So if we look at the next resolution chart, as an example of some resolutions, up to 4 CIF, as you see towards the bottom of the chart, 4 CIF equating to 0.4 megapixel is where we were in the analog world. As we move to IP, typically speaking, 0.5 megapixel and beyond, typically up to 12 megapixel, but can be up towards 30 megapixel. The 4 CIF equates to 0.4 megapixel. So if you are trying to gauge how much better an IP camera is, or higher resolution camera, to an analog camera, that's your rough equation. So if you take a 2 megapixel camera, it's approximately 5 times better than its best quality analog camera. So the question is, why is that important? So if I take a typical scene, garage forecourt. So if I go what we would have had probably 10 years ago, we had a CIF quality recording. So there's a garage forecourt, we have a CIF image. If you look along the bottom, 352 pixels. So the resolution of a CIF image was 352 by 288 pixels. So you have 352 pixels along the bottom, and you have a 30-meter width in the scene. That equates to 11 pixels per meter. As you start digitally zooming in to try and get detail from that scene, you can see there's really not a lot of information there. On the overall image gives you an overview, but you don't have a lot of detail there. If we go to 4 CIF, we now have 720 pixels along the horizontal. You now have 24 pixels per meter instead of 11. So straight away we can start seeing more detail in the scene, but it's still not there. There's not enough detail really to provide evidence in a lot of applications. If you look at the gentleman on the top left, you can make your own mind up. The first time I looked at this, my best guess was a pair of brown shoes or red shoes, probably jeans, black top, but you really can't tell the detail from it, nor can you tell number plates in this application. If we move to 3 megapixel, so we now have 2048 pixels across the same width. So we've gone from 11 to 24 to 68 pixels per meter. As we digitally zoom in, you can now see a lot more detail in the image. So we can now see this gentleman's wearing tracky bottoms, white stripe down the leg, red trousers, partial number plate just from that snapshot we look at the moment. So straight away we have a lot more detail. We don't have facial recognition, but we have enough detail, that coupled with other cameras potentially within the store, to provide evidence so we can lead to prosecution. The same as we move through for number plates. Again, in that scene, we can capture number plates a lot more clearly. Now these pixels per meter are the makeup now of systems. Depending where you read it, which guidelines you read, there's some differences. As a guideline, and I'm taking as a summary of what's really out in the marketplace, detection is at approximately 50 pixels per meter. Detection being just to see something's going on. Observation is 100 pixels per meter, and that's just to look and see a little more detail and try and analyze what's going on. Recognition is for me to recognize somebody that I know, and identification is to recognize or to get somebody who I don't know and to be able to use that as evidence. If you equate that to a 2 megapixel camera, which is really about the industry norm at the moment, albeit that is increasing, a 2 megapixel camera, approximately speaking, will give identification on a scene width of 6.4 meters. There's other factors come into consideration, but that's as a guide. If it's just purely detection, then it's scene width of 38 meters. Okay. The idea that's just to help with some of the designs that you're doing Again, there's more advanced tools that can be used, but just as a guide. So if we look at this, we've said all along, more resolution is better. But if you look at this camera behind me, there's two cameras. The top camera is 1.2 megapixel. The bottom camera is 10 megapixel. Which image is better? If I have 10 million pixels on a scene, on a camera, and all those pixels are all white or all black, it's of no use to you. What's important is the quality of the camera and the quality of the image it generates. Everything has to be in contrast. So that's a wide dynamic scene. The bottom camera wasn't able to deal with it. The top camera was. As a result, we have more detail from an evidential point of view on the top camera, which happens to be a lesser resolution and probably is a cheaper camera. What's also important to consider is lighting for megapixel technologies. As you increase in resolution, you need to consider the lighting that you have available to you. The reason for this is pixel density. Very simply, if I have an amount of light shining on either of those two chips, each pixel on the right-hand chip will receive less light. So the reason being, it's higher resolution. So you need more light considerations for higher resolution scenes. If you equate that to your network design, you equate that to your bandwidth for storage, the scene on the left, black image, is producing a bit rate which results effectively in 1.4 megabits of storage. The scene on the right is using infrared lighting, is resulting in storage of 0.05 megabits per second. That's a 96% saving in storage, all because it's better lighting in the scene. Now, that's not necessarily true for every camera manufacturer, but as a generalization, improving your lighting will improve your CCTV system. How does it work? More light basically means you have less noise in the scene. And a consideration for some manufacturers is you see that during the day their camera may be streaming something around 5 megabits per second. At night time, their stream may jump to 40 or 50 megabits per second because of the noise in the image, and they haven't the ability to deal with it. And that goes back to the previous slide. So more light means less noise, which basically means you get higher quality pictures, which means you've got your video compression working more efficiently, and effectively then you can get a 90% saving potentially on bandwidth and storage. Also, you've got the ability for video analytics to work if you've got good, even lighting throughout the scene. So what do you do if you can't get light to a scene for possibly environmental reasons or some other considerations? Well, you have the option of thermal imaging. Thermal imaging is becoming more common and certainly can be used on sites to monitor certain applications. It doesn't necessarily have to be because there's no light. It can also be because there's too much light. If you look at the scene here, this is monitoring a road. The car headlights are causing the optical camera difficulties, but the thermal image sees an even image whether it's day or night. You won't get levels of detail from this camera that you will from an optical camera, but for monitoring purposes, it works very, very well. Typical application for thermal is perimeter fences and the use of analytics down the fence. So you can see on the scene we have here, tripwires down the fence, and as somebody walks through, each of those zones can be triggered to activate an alert to an operator. That scene doesn't change whether it's day or night. That's what that will always look like to the system. Another side of thermal is thermography. So slightly different chipset than what's used in the security industry, but it's something that is becoming more commonplace for us as a manufacturer and for others as well. We can also use the thermography technology to monitor temperatures in an area. So we can have threshold temperatures. Once it goes above or below a certain value, generate an alert, or if a temperature increases by a certain amount, generate an alert. So on the right hand side, the smaller image, you can see an electrical substation. It's monitoring the outputs from the transformers. On the main image, you can see this is on a uranium plant in South Africa. You can see basically temperature alerts up certain storage devices. So if storage gets to a certain area, it generates, or a certain temperature, it generates an alert to an operator because they know something is wrong. So analytics I've mentioned. Analytics are very much commonplace now for most main manufacturers within the industry. So some of the analytics that are available. So automatic tracking of people and vehicles. So if it's a pan-tilt zoom camera, you can have analytics in the camera. The camera has the ability potentially to follow people around the site. It works best on clean sites. If you have lots of noise, lots of activity on a site, the camera doesn't know who's the best person to follow. There's certain rules you can put in, but it's never perfect. On good, clean, sterile type areas, these technologies work very, very well. You have the ability for directional motion. So perhaps in an airport where you're allowed to go one way from arrivals, but not the other way. If you're seen to go back in, it can generate an alert and allow somebody to attend. Adaptive motion. Two things with this. It allows you to see where the person's come from. It creates like a snail's trail behind, so you can see where they've come from and where they are at that point. But it also adapts to the scene. So if you've got a noisy scene, if you've got trees moving and so on, these analytics can adapt and say, this is normal, I can rule these out. Object counting, again, could be people, can be just various objects. Loitering, stopped vehicles, abandoned objects, all work on the same general principles of something's left in the scene that wasn't there 2 or 3 minutes ago, or whatever the alert period may be. Object removal, so again, art galleries and so on, if a painting's gone missing, etc. And finally, sabotage. Sabotage is a fairly basic one. It's there, available in most cameras, that you can have, if a camera scene is either covered or changes dramatically, i.e. somebody's moved the camera away, it can generate an alert, draw an operator's attention to the issue, there's an issue on the system, or somebody's tampering with the system. So largely speaking, that's your camera technology. There's a lot more detail within that, but as a high-end overview. If we look at the command and control side of things, the considerations here, from storage firstly, what type of storage do you want? Do you want to go software only? So again, Michael mentioned video software as a service. Do you want to go software only and do you want to push your storage off-site? Realistically, where we're at today with bandwidth availability and so on, it's not a viable option for most sites. Small numbers of cameras, potentially it can be, but most sites tend not to be. However, backups can be done off-site for risk reasons. So if you are choosing hardware, what type of hardware do you need? Is it a hybrid solution? Do you need analog cameras to come into this, or is it purely IP? If it's IP, then it's an NVR. If it's enterprise class, do you need a simple box that if it fails, it doesn't matter? Or do you need a system that's got fault tolerance built in, redundant power supplies, redundant drives, etc., etc.? And ultimately, where you want to grow this system to. Will the hardware be purpose-built, or do you wish to use commercial off-the-shelf technology? If you're using commercial off-the-shelf product, have you considered system management, defrag, system cleanup? We all know what it's like with laptops and PCs. Every so often we have to do maintenance on them. Has the system got the ability to do that without shutting down the recording? Are you using the correct hard drives? So on a CCTV system, the system is writing constantly, but very rarely will the user actually view video off those drives. On your PC, it's the other way around. You tend to write maybe once and you read multiple times. So those things have to be considered not only in the hard drives, but also in the storage boxes themselves. Throughput considerations, as say we've mentioned numbers of cameras, the bandwidth from cameras, day and night, etc. For reviewing, viewing live, for recording, for reviewing. All these things need to be considered. And that's where working with a reputable manufacturer, you'll have that information to allow you to design the systems correctly. Again, you need to consider what licensing, what support agreements are required. Again, is it recurring licenses? Is it specific to MAC addresses for particular cameras? If it is specific to a MAC address, what happens 5 o'clock on a Friday when you've got a camera failure that's critical? You know, can you get a license for a replacement camera at 5:30 that night to get the user up and running? If we look at the storage specifically, what's commonplace is JBOD, just a bunch of disks, is what it stands for. First in, first out. RAID 5 basically allows one hard drive to fail and the system carries on working without any loss. RAID 6 allows 2 hard drives to fail and the system carries on without loss. The logic on a RAID 6 system is you'll call your installer out, he determines, yes, you've got a faulty hard drive, you may not have a spare, he goes off, he gets one, comes back a day later, a week later, whatever it may be, puts it in and discovers another drive's failed. with RAID 6, not an issue. Put that drive in, go off and get another one. System's fine. With RAID 5, that would have caused the entire system to fail because you would have had 2 drive fails at one point in time. So you just got to consider what's required, what's reasonable within the system. Storage calculations are important. And again, your installers, your manufacturers will be able to help you with this. There's some critical things we need to know to do storage calculations. Most manufacturers will have very similar bit rates. In other words, the traffic the cameras are generating. So what's important to know is the resolution of the camera, the number of frames per second, and the amount of time you want to retain that footage for. The other key factor is the activity level. So the question is, do you want the system to record continuously all the time, or do you want a system to record potentially on motion? There's an argument both ways. Using motion will save storage, but there's a possibility you may lose certain critical events. There's a recent court case where an employee went into a till at lunchtime in a shop, took money out, went off, bought their lunch. When they were out, they went to the ATM, they got the cash, and they put the money back into the till. What had happened, the CCTV system recorded them taking the money out, but didn't record them putting the money back in. The system was on motion, went to court, and because it was on motion, on purely motion, the system was thrown out of court. There was no continuity of evidence. So the employer was not able to reasonably show that the system worked and showed that the employee put the money back into the till. One way around that is you can record continuously at 1 image a second, and on a motion event, you can increase to potentially 25 images per second. So it's just something to consider. There's still some debate about it in the industry, but it's something to consider. So we look at the hardware selection. We spoke about the storage, but we also have to look at some of the intelligence within the system. So analytics may be on the cameras at the edge, but depending on the manufacturer's products and the integration you need, you may choose to have a central analytics box. And that could be a central server that pulls everything together. So you may need to consider, do you require something additional centrally? How many operators do you need in your system? Today you may only need 5. Next year you may need 35. Is the system ready to grow to that? Will that be through software expansion? Is there additional licensing and so on required? Those are the considerations. As we mentioned, with the storage, the frame rates, the qualities. Do you require remote connectivity? Is it just locally within your network? And indeed on the network, is it going to be on your own dedicated security network, or is it going to be on the corporate network? What considerations you have then for mobile apps and remote access, maybe from third party or from remote sites, or indeed monitoring centers. So all those things have to be considered, along with third party interoperability, which we'll touch on shortly. You have options for software. We spoke earlier on the commercial off-the-shelf hardware. So you can choose software. So you can choose software from vendor 1, you can choose hardware from vendor 2, and you can choose cameras from vendor 3. How do you know it all works together? The short answer is there's no easy way. You're reliant on your manufacturers, your installers to tell you this is going to work. I think generally what I would recommend is demonstration of proof that this is a solution that's tried and tested and proven. Again, we touched on the licenses. Depending on the solution, if you go software only, I think there will be licensing involved. Is that licensing basically time-bound? So, i.e., you've got free licenses until the end of the year, or licenses included till the end of the year, at which point in time your system switches off, and it does happen. Or are they feature-bound? You know, have you purchased a system that's very, very basic and you want to enable another function, and you've got to license that? So those are questions just to try and understand. Again, we mentioned specific to MAC addresses of the camera, which basically means you can't interchange cameras without a specific license. And if it is the case, what is the process for licensing? So back to that Friday at 5 o'clock, how do you add a camera on? Do you have to speak to somebody in an office who's now gone home? Or is it an online automated process? Video surveillance service we've spoken about, and I say it's something that will increase and you will see more and more. So in terms of functionality, system compatibility is critical. Is it backwards compatible? Is it forwards compatible? Backwards compatibility, what I mean by that is if I go to somebody today and put in a new system, Can I take care of their investment that they've made over the last 5-10 years? Can I bring their analog cameras into the system? Can I put in the IP cameras that they've maybe purchased over the last couple of years and bring those into the system? That's important. You're protecting the investment. You'd be surprised to know that some manufacturers don't do it to products that were manufactured last year. Products that people have bought last year, they want to add a couple of cameras and can't add cameras into it because that platform's no longer supported. They've moved on to something else. The IP technology is moving very, very quickly, and it's something that you have to be aware of. Forwards compatibility in that ilk, we currently sit with H.264 compression. What we're seeing now is H.265 compression. It's only just started releasing. But for example, us as a manufacturer, the products we release today have the ability to migrate to H.265. It may be software features, it may be hardware features, but it's important to know that your chosen manufacturers have the ability to move forward as technology moves forward. Camera support, not only say the compression, you have to have specific drivers in there, but what level are those drivers at? It's one thing to tick a box and say, yes, I'm compliant with somebody else. But what functionality do you have? Do you have full pan tilt zoom functionality? Can you call presets? Can you call patterns? It sounds simple. It doesn't necessarily follow that it will work. Do you have motion? So back to what we were saying earlier, do you want the system to record or increase frame rates on motion? If you're using a third-party camera, you may not be able to do that, depending on the level of integration that's in place. And the same with analytics. If you're using multi-sensor or 360-degree cameras, have you the ability to de-warp, i.e. to take that round object or that round image and zoom in on certain areas and de-warp that out? If you can do it live, can you do it when you export the image off? So these are all things that have to be considered. They sound obvious, but believe me, in the industry we're in, not everything that should be in place is in place. From a user perspective, it's important to understand an operational requirement which you may or may not generate, or maybe done by somebody within the organization, but to understand what the user wants from the system. So typically speaking, you want from live video, uncluttered live video, monitor walls, ability to display high resolution cameras, the ability to simply review footage, thumbnail search, metadata searching, very, very simply retrieve information from a system. What you find is many operators will not export footage or look for footage on a regular basis. It may happen once a month, it may happen once a year. So it's important that when they do come to do it, that it's intuitive. Overall, the ability for users to share video. So if I'm sitting in a large hospital type complex and I have an operator at the far end of the hospital, perhaps an A&E, I need him to see somebody who's coming his way. Have I the ability to simply drag and drop an image onto his monitor and push information to him? And I say, we want to do all this with minimal training. Ultimately, the users are there, they're multitasking. You don't want to spend time training them up, or you want to reduce the time to train them up. One of the things is investigation capability. Now, every manufacturer does things differently, but just as an example, you walked in here today, there's probably a camera outside the front door. So camera 1, I want a little bit of footage from 855 to 856. You walk through reception. So camera 2, I want from 856 to 857. Camera 3, you want, etc., etc. You have the ability to take all that information, cut and paste that together, if you like, into a playbook, so that when I then give that to either somebody within the organization or somebody from a legal perspective, that you've got continuity of evidence and the story makes sense. I can see that I walked in here this morning, I tripped and fell on the step, and I'm putting a claim in. So you've got that continuity. There's no doubt. It's simple for people to see. Network. Many of you in the room are well used to designing networks. The thing is, in the security industry, many of us aren't. Many of the traditional security installers still are very, very comfortable with Analogue, but are only becoming comfortable with IP. Many of them haven't trained up yet to become IP professionals, and they're learning on the job. So a lot of the time, the network is something that they may not want to get involved in or may not be fully versed in. Again, I would encourage you at that stage to reach out to the manufacturers, to work with them in those circumstances to make sure that they've got the information that's required for network design. If the network is wrong, the system will not work, period. So in terms of topology, standard networking principles apply, standard topologies apply. In the simplest basis, core switch with all devices off it is what you need. On a more distributed system, you can start bringing buildings in. You can start potentially VLANing and segregating sections of the network off. In the core switching, you can see there's 3 switches there. We can have, in any circumstance there, one of those switches can fail and the system will remain live. So you can start building redundancy into the system. But you also have to look at this and say, well, if a certain section of that network goes down, what's the impact? Or if the security office need to view all cameras from site for some particular reason, can that link on the network cope with that? That all has to be done at the design stage. Cabling, again, I'm not going to spend too much time on. You're aware of network considerations. Copper is 90 meters plus 10 meters of patching. Fiber for multi-mode, depending on the cable, on a switch, typically tends to be around 550 meters. On a single mode, it tends to be up to 1300 meters. From a security application, that on the analog world, that tended to be significantly greater. But from an IP world, that tends to be where it's at. There's arguments over Cat 5, Cat 6. We're into the Cat 7 world now, but typically the recommendation would be Cat 6 wherever possible. The reason for that is faster frequency response and a better noise crosstalk. If you have issues where you need a camera on a remote location, maybe a car park, whatever, but budgets maybe don't allow for fiber, etc., then Ethernet over coaxial. Or if you have existing coaxial cable, you can use an Ethernet device over that cable. Again, it's technology that's becoming very, very commonplace. So choosing your switch, what do you need to consider? All the standard stuff. Number of copper ports, i.e. the cameras and so on, that are going to be off this. The PoE requirement. So what power is required? Is it class 2, class 3? Is it HPoE, etc.? What requirements are on each of the devices that's going to be on that network? How many fiber ports? Do you need fiber out to those camera poles again, or do you need fiber between switches? Again, the type of the fiber port, single mode, multi-mode, because it'll depend on the module that gets used with it. The throughput, is your switch capable of taking all this extra traffic? And if you're using video on a corporate network, are all the bandwidth calculations in place that people understand what the impact on the network is going to be? And how they can mitigate that through VLANing or some traffic management. Types of traffic, will your switch support the protocols? So for example, we have the ability to use multicast traffic, which is still not massively commonplace. The advantage of it is it means you can pull up multiple cameras for very, very low bandwidth. But many cheaper network switches cannot deal with that. So if it's something you require, then your network switches have to be up to par. Do you need fault tolerance? Do you need the ability to scale in the future? So if we look at integration, again, Michael touched earlier on just on integration that we've just completed with ACT. But in general, there's levels of integration. So the key thing is integration is one of these tick boxes that a spec comes out, you need to integrate to ACT. Tick. But what level of integration? Is it a case that ACT can sit on the same PC client that I have my software on? Or do you need some level of interoperability? I think it's important to try and detail, even at a basic level, what you require from the system. That integration could be as simple as a contact closure. So an intruder alarm activation comes off, we get a simple contact closure into a CCTV system and a video pops up on a screen. That could be the same for 232, or typically it's more IP linked. So for example, here's an integration with a point of sale company. I'll show you a larger shot in a moment. But the same follows for number plate recognition, for access control. It all works in this same sort of way. So here's a casino. Down the right hand side, you can see that we have data coming through from the table. This is a casino in Las Vegas where this is legal, but each of these cards is RFID tagged. So as it comes out of the hopper, which is probably not the proper word, but anyway, shows my gambling experience. As the card gets issued out, the houses are able to see which hand the player's holding and the banker's holding. All the graphs indicate the odds of the house winning. So all that information is stored, and that's basically brought in on our CCTV system in this instance. So you have video there, but you have all that pause data there. You can take that pause data and supplement that for access control information, for doors left open, for who were the last 5 users through, etc., etc. It's up to you. The integrations can be developed to a very, very advanced level, but we need an indication from yourselves what you want to achieve. Design tools, every manufacturer will be different. And installers you speak to will have access to these tools, and indeed, if you go online, you'll find access to these yourselves. Camera placement tools allow you to plot 3D views within CAD drawings, etc. Field of view calculators, storage estimators, Autodesk Revit files, etc. There's camera selection apps, viewing apps. There's knowledge bases there for answering some questions, websites. Every manufacturer will have something that's relevant. So at the very start, we touched on OnViv. And OnViv is basically the common platform, if you like, now for video security. I want to touch just briefly on the 4 profiles, very, very briefly. Firstly, OnViv Q. So I think the first thing that's important is to understand that when a manufacturer states they're OnViv compliant, is to understand what level of OnViv compliance they state. On most manufacturers' data sheets, they will detail that. So if you pick up one of our data sheets, it will state it's P, it's Q, it's S, it's G, it's whatever. You'll have that information. And not having them all may not be an issue, but it depends what you want to achieve. So OnViv Q is out-of-the-box interoperability. So it's discovering the device on the network, it's being able to monitor that device, and to be able to push updates and so on to that device. So in theory, I can get any camera, along with my recorder, and put the two together, and it'll work. That's the theory. OnViv S takes it a step further. So this now brings in not only getting the device to work, but pan-tilt zoom, the audio, metadata, relays, ability to stream information from the devices. OnViv G relates to local recording on the device. So if you have a camera and the power fails on it, let me start that again. If you have a device and the network goes down, you have the ability, as long as the camera is still powered, to record to an SD card within the camera. You could then go back when the power's back up and retrieve that footage off the camera. So that's OnViv G, and that's what that standard's all about. And that gives interoperability between us as a manufacturer and other manufacturers. The latest one that's coming out is for access control, so it's Profile C. Not commonplace yet. There's actually very little discussion on it, but it's now out in the public domain. And that allows the ability to pull information from devices, so the doors, the users, the states of the user, the door left open, etc. So the whole idea of OnViv is to start bringing all these things together. OnViv over the last number of years, approximately 7 years, have gone from being quite fluffy to being quite detailed, and are now very much the leading authority, if you like, on the standards. There's another standard which is PSIA. Realistically, it's a standard that's dropping and diminishing away. Most people will work to an OnViv standard. The theory is that any OnViv device will interoperate together. In reality, it may not be the case. So again, if you've got specific requirements for specific functionality, talk to your installers, talk to the manufacturers, and have them determine what works and what doesn't. So just to sum up, why IP? Analogue is going end of life. So realistically, us as a manufacturer and various other manufacturers are no longer investing in research and development for Analogue products. We have just end of lifed a lot of our matrices products and so on, due to difficulties in getting components and due to difficulties in developing those products further. You can use your existing infrastructure potentially. It's cost effective. Potentially you can replace one or multiple cameras with a single camera. That camera can be powered over the network rather than bringing separate electric supplies, etc. It's scalable. Depending on the system you choose, you have the ability to start with 2 and 3 cameras and grow up to many, many thousand. It's easy to manage from a central point. So in things like remote focus, remote setup on the camera, you don't necessarily have to get a high lift and get out to the camera itself. You can set things up from a PC in the comfort of the control room. There's image improvements, and one of the key things is the global standards. So because we have global standards, forums from all around the world, manufacturers from all around the world, are all developing together in the same direction. So as technology, if it's not available today, chances are somebody else is asking for it somewhere else globally, and all these things will be developed together. Whereas before, we had many coexisting standards and developments. Thank you very much. Hopefully it was of some use to you. I'm leave the questions until the end of the forum. Thank you.